Yes, my name is Kristina Lukas, and I would like to present my master thesis that I did at the chair of timber structures and building construction last year. And the topic of the thesis was sustainability assessment of fire protection measures in timber construction. So we all know we already have a global warming of 1.1 degrees Celsius due to anthropogenic climate change, and the the construction sector has a large impact. The construction sector makes up 37% of the global CO2 emissions, and this has a large potential to also improve these emissions. Since 2002, with the German MBO framework, it's possible to construct in Germany in timber, and now we can use biogenic materials which have low greenhouse gas emissions to reduce the impacts of the construction sector. The thing is, as the others already said, with the timber constructions, we have regulations for fire protection systems, and so we also have the questions: how do these fire protection measures in timber frame and mass timber buildings, especially for the building classes 4 and 5, impact the ecological sustainability? And can changes in cladding thickness and in the insulation material lead to significant improvements in the environmental impact of our constructions? So for the research methodology, I firstly created a component catalog, which I developed for load-bearing internal walls based on the building regulations, especially on the already mentioned Musterholzbau-Richtlinie, which was updated last year. And some of the components I looked at, you can see here. You can see that I looked at both timber frame and mass timber walls. You can also see that I considered biogenic insulation, which is in Baden-Württemberg also possible to use in load-bearing components. And I also looked at the impact of installation layers. For these components, I then did a component level analysis where I did life cycle assessments, short LCAs, for these interior walls. And then I took it on the building level and did a building level analysis where I did LCAs for a reference building, which is shown on the right here. It's a building situated in Munich, and it is a building class 4 building made out of timber. And for this building, I also created variants, which firstly, I did a variant where I considered biogenic insulation, which is possible in Baden-Württemberg, as I already said. I used the biogenic insulation in load-bearing parts also. Then I did a variant with reduced cladding for the interior walls mostly. Then I did a variant with reduced concrete where I exchanged the staircase to a timber staircase from a concrete staircase. And lastly, I also looked at a concrete reference building for reference, yes. So afterwards, I created some recommendations for action and also a conclusion and a discussion. So I would like to explain my component level findings based on this graph. So on the bottom here, you can see the different components that I looked at. And on the left side, with the dark blue graphs, is the GWP, which is the global warming potential, which shows the greenhouse gas emissions of a component over the entire life cycle, also including the end of life. And then in light blue is the primary energy, the primary non-renewable energy used also over the entire life cycle. And my analysis showed that there is definitely a benefit in reducing the cladding because there is a reduction possible with the new updated Musterholzbau-Richtlinie compared to the old Musterholzbau-Richtlinie. And this, this reduction you can see here from the CLT standard to the CLT reduced, for example, there's definitely a reduction in the values. Also, which is not shown in this diagram, you can see, or I saw in my GWP values and primary energy values than gypsum fiber boards. Secondly, I looked at the biogenic insulation, and I found that right now it's a bit challenging. Or with the Musterholzbaurichtlinie, with the Holzbaurichtlinie in Baden-Württemberg, you need an additional layer of OSB if you want to use cellulose, for example, in a load-bearing component, and this leads to high environmental impacts. Also, you can see that biogenic insulation has a shorter lifespan than mineral wool, for example, and thus you need to exchange it during the life cycle, which also leads to higher emissions. Lastly, I saw that there's an installation layer impact, which is about 15%. So if you want to have an installation layer in your wall, GWP and your primary energy increases by around 15%. Okay, let me fix this for a second. So this doesn't fall off. Yes, this is better, I think. Okay, sorry. So, yes, on a building level. On a building level, I found that the gypsum definitely has a big impact on our environmental, on our environment. You can see that it adds up to 12 to 15% of the GWP. So here in the graph, you can see it's the GWP of the reference building, and about 14% of it accounts from the gypsum, or comes from the gypsum. Secondly, you could see that the timber buildings definitely have a better GWP than the concrete variant, which is shown here. Those two timber buildings have way lower GWP than the concrete reference building that I looked at. But, however, you also saw that the optimization that I achieved by reducing the cladding is limited when you look at it at a whole building level, because only on a few walls you could actually reduce the cladding. For many walls there are fire requirements like a firewall, and thus you cannot really change the cladding following the new Musterholzbaurichtlinie. So the reduction is only by around 2%. So overall I can say that it's environmentally speaking a good thing to choose timber in building class 4 compared to concrete. You could also see that you should try to minimize the cladding that you use. So reducing the fire protection cladding to the required minimum thickness definitely gives you a better environmental option. Thirdly, you should avoid unnecessary OSB. So OSB is often structurally necessary, or it also serves for building physics reasons. And if it does that, then we definitely should keep it. But if it could be, for example, exchanged for something different, then maybe it's a smart option, because OSB has a rather high GWP and primary energy demand. And the same thing is for the gypsum fiber boards. If it's possible, then maybe it could be exchanged to gypsum plaster boards, which have way lower environmental impacts. And then lastly, choose the insulation carefully. If there are additional layers of OSB or other fire protection methods necessary, then often the use of mineral wool is actually better than the use of biogenic insulation. But if that's not the case, then biogenic insulation is a good alternative, or even a better alternative, environmentally speaking. Okay, lastly, I'd like to talk about some of the limitations and future research. So the LCA methods applied definitely need some improvement, especially considering biogenic carbon and the consideration of material reuse. Also, the Ökobau data sets, which were used for this analysis, need some validation, especially looking for gypsum products and the end of life of gypsum products. And lastly, it would be interesting to have some innovation in the direction of maybe low impact OSB alternatives and smolder resistant biogenic insulation. This insulation could be used following the Holzbaurichtlinie in Baden-Württemberg, and then you would not need the additional layer of OSB, which would then lower the GWP. Here are some of the sources that I used, and I thank you for your attention.